get to building your first Node app. When I'm working, I like to keep at least two things open. First is my text editor so that I can write and edit the program, and I also sometimes use this to browse through the folders in the directory that I'm inside of. And the second is my terminal, so I can run and test the application and see the debug messages, etc. Later on, when we're building the web app front end, it's also useful to have a browser open so that you can test it. When I'm building an API, I'll also often have an API tester like Postman open. For now, these two windows are fine. For the purpose of this video, I'm going to collapse these windows into one screen so that you can see the text editor on the left-hand side and the terminal on the right-hand side. Normally, I wouldn't do that. I would just kind of toggle between the screens, but toggling back and forth would make this video very dizzying, so I'm just putting it all in one. If you're going to code along, go ahead and open up your terminal and your text editor, if you like, so that we can get rolling. Now, to recap, in this section, we're going to be building a RESTful API for an uptime monitoring application using no NPM modules, no dependencies, or anything like that. We will, however, be using a large chunk of the features available in the Node.js library, and I'll point out what each one of these is as we go along. Several sections from now, we're going to go back through this code and add some tests and refactor a little bit to make it better and more robust overall. But for now, we're just going to build a quick and dirty application. As I mentioned, we're building an uptime monitoring app. This is an app that lets you, as a user, enter a URL that you want monitored, and it'll send you alerts if that URL goes down or comes back up after being down. You're probably familiar with a lot of uptime monitoring applications available. We want this app to be usable in the wild, so let's make sure that our users can sign up, sign in, sign out, then edit their settings, in addition to just being able to make uptime checks and that kind of thing. Also, we want our users to get their uptime alerts, their up alerts and their down alerts via SMS instead of email, so we're going to be integrating that way. Before we get to coding, let's spec out our requirements here. What is this API part supposed to do? We want a RESTful API that, 1, listens on a port and accepts incoming HTTP requests for post, get, put, delete, and head. 2, we want the API to allow a client to connect to it so that they can create a new user, edit that user, or delete that user. 3, we want users to be able to sign in, and we want that sign-in mechanism to give them back a token that they can use for subsequent authenticated requests. If they want to do something that requires being logged in, they're going to need to provide that token that they got when they signed in the first time. Number 4, we want that same user to be able to sign out, and we want their token to be invalidated, or we want them to be able to invalidate their token when they sign out. Number 5, we want a signed-in user to be able to use that token to create a new check. And by check, we mean a task for the system to check a given URL to see if it's up or down. We also want the user to be able to define what up or down is. For example, for some websites, up might mean that you receive a 200 status code, while other websites might say that for us, an up is anything that isn't 500. Number 6, we want a signed-in user to be able to edit or delete any of their checks, and we want to limit their checks to 5. So we don't want a user to be able to create a 6th check. We want them to be able to have 0 through 5 checks. And 7, in the background, we want to perform all the checks at the appropriate time and alert the users when a check changes its state from up to down or vice versa. We want our checks to run once a minute. So once a minute, we want all the checks created by all of the users to run. We want to check those URLs to see if they're up or down, given the definition provided by the user. And if it is currently down when it had been up, we want to send them an SMS. If it is up when it had just been down, we want to send them an SMS. Otherwise, if it doesn't fit those two conditions, we just want to do nothing. Okay, so that's pretty much our requirements for the API. There's a few other little things that we want to be able to do, but we'll walk through those as they appear. For For the majority of these features, we'll use the plain Node API, but to alert users via SMS messages, we use Node to connect to the Twilio API to send SMS to the user. Though this doesn't mean that we'll be using a third-party library to connect to Twilio. We're actually going to craft the HTTP requests by hand, and I chose this integration because I wanted to be able to show you how it's possible to interact with APIs from plain Node itself without needing a library from that vendor. Also, since it's a fairly simple program, we will be writing to the file system rather than a traditional data store. If we were building this program for production, it would be worth integrating with a true data store, possibly through a library, but that's outside the scope of this course. For us, we're just going to be writing JSON files to the file system and reading them as if the file system was a key value store.